Alright, so here's a key to today's calc assessment. First problem, number 1, let's take the derivative of, let's see, we got natural log of 5x plus x squared to the 4th. Alright, so this chain rule, I've got 4 functions, really, 4 things to consider. There's my outermost function. There's my next inner function. There is my innermost function. They're all layered, right? 5x plus x squared sits inside the natural log, which sits inside, x to the 4th. So the derivative of the outermost is going to produce this. So we got natural log 5x plus x squared. Okay, check that one off and go to the next inner. That's natural log. That's going to produce this 1 over what you got. Okay, then go to the most inner, that derivative. Right, so multiply by 5 plus 2x. And there you go. That is your answer to number 1. I don't need you to simplify it right now. Okay, number 2 was about combining rules to find derivatives. So we got, sine x times cosine x divided by x to the 2nd power. So I see quotient rule, I see chain rule, and I see product rule. So the outermost function is the squared function. So the derivative of the outermost is 2 times, what you got, sine x times cosine x over x. Now you got to go to the derivative of the inner function. So inside these parentheses, this is what you have. Well, you've got a quotient in there, sine x cosine x over x. So there's the numerator, right? You're going to need the product rule to evaluate the derivative of that numerator. So I'll break this up for you a little. We're going to go low d high, so low times d dx of sine x cosine x, low d high, minus high sine x cosine x, d low, the derivative of x is just 1, all over low squared. Now, it's fine and dandy, except you don't want to leave this in your answer. Right? That's the last thing you need to do, is take care of what's in yellow there. So you just need to apply the product rule to sine x times cosine x. So just as a side note, if I said, what is the derivative of sine x times cosine x? Okay, leave the first one alone. Derivative of the second one. Right, so I left the first one alone, and I did the derivative of the second function. Plus, leave the first one alone. Or no, we just did leave the first one alone. Leave the second one alone now, right? So you're going to recopy cosine x. And you'll do the derivative of the first one. Okay. The derivative of sine is cosine. So if you simplify that, you have negative sine squared x plus cosine squared x. So this stuff is going to replace what's in yellow there. So our final answer, 2 sine x cosine x over x times x multiplied by, so that's this x right here, and the yellow turned into negative sine squared x plus cosine squared x minus sine x cosine x. Okay, that's just this stuff right here. It's right here. Okay, and then we're all divided by x squared. I don't need you to clean that up right now. That's where we're going to sit. That's our answer. So right there. You can stop right there. Alright, so I'm just going through reviewing that one. There's certainly a lot of places you could make mistakes. So I did my chain rule. Then when I went to the inner function, which was the rational piece there, I said low d high minus high d low over low squared. So as I check, there's my low, there's my d high minus high d low all over low squared. So I'm good. Alright, next problem was number 3 on your assessment. And number 3, we said y is equal to sine x raised to the x squared plus 1. So you've been asked to find y prime. You started with function to a function, so before you get to do any calculus, you're going to rearrange this thing a little. You're going to take the natural log of both sides. So that just ln y is the natural log of sine x to the x squared plus 1. So this exponent gets to move out in front of the natural log. So x squared plus 1 now sits in front of natural log of sine x. There's properties of logarithms. We say, the natural log of smiley face to the star is, erase that, is star natural log of smiley face. Just properties of logarithms. So I just use that property. Now I haven't done any calculus, I've just rearranged this thing. So I'm sitting here at this line in green, and I still don't have y prime. I mean, that's the goal. But I'm now in a position where I can handle the derivative of both sides, and y prime is going to show up. So when I get to differentiating the right-hand side, just realize you're going to have to use the product rule, because you got these two pieces multiplied together. So d dx of the left equals d dx of the right. Right? If two things are equal, then their derivatives are going to be equal. So if you want to think just algebraically, what I'm doing to both sides is I'm taking the derivative of both sides with respect to x. Okay. So the derivative of the left with respect to x, well, that's the derivative of the natural log. Okay, that's my outer function, so 1 over y. The derivative of my inner function, well, the derivative of y is y prime. You might be saying, that looks like a variable, not a function. Well, you're taking the derivative with respect to x. So when you take the derivative of y with respect to x, y is like a function. Okay, it's a function of x. So that's why y prime shows up. So the right-hand side, I got product rule, so I'm going to leave the green one alone. Do the derivative of the blue one plus do the derivative of the green one and leave the blue one alone. Okay, I'm almost there. Now I can clean up the right side a little. It's cosine x times x squared plus 1 over sine x. Right, these are all just fractions. All the way across the top, all the way across the bottom, you multiply. Plus 2x natural log sine x. And that equals 1 over y, y prime. So isolate y prime by multiplying both sides by y. So y prime falls out over here. Now I'm going to have to multiply the entire right-hand side by y. So I'm going to recopy this again. Cosine x, x squared plus 1 over sine x plus 2x natural log sine x. Oh, we're almost there. Now, that's pretty good. You're almost there. Actually, really good. But you still have y sitting over here. So right now your derivative, y prime, is a function of both x and y. Y prime equals, so notice if you're going to calculate y prime, if you look at the right hand side, it's going to take knowing x and y. One convenient thing about substituting in for y, like if we go back to the beginning of the problem, it said that y was actually equal to sine x, is it to the x squared plus 1? Yeah, so if I replace that, now my derivative is just a function of x. And it's now actually much more useful. So this is your answer. So you have used logarithmic differentiation, right? You ended up with y prime. You were asked to find y prime. You were looking at function to a function. You took the natural log of both sides. You rearranged some things. Took the derivative of both sides. In the end, you ended up with y prime equals. The last problem is, I know it's kind of related to the 3. Xy plus y cubed equals x. And I say it's kind of related because as I start this problem, I'm not going to be able to isolate y, and I guess in the last one it started as y equals, but y isn't isolated. So I start by saying, well, so what if the left side equals the right side? Doesn't that mean that the derivative of the left side with respect to x is equal to the derivative of the right side with respect to x? And that's obviously true, right? If both sides are equivalent, then their derivatives are. So the goal, I should say, that we wanted to find y prime. So in the initial problem, xy plus y cubed equals x, I didn't see y prime anywhere. Now if I take the derivative of both sides, pay attention because y prime is going to show up, and then your task will be to isolate it. So on the left hand side you want to take the derivative of xy plus y cubed. Well, that plus is pretty convenient. It allows you to break this up and actually say, well, I actually want to find the derivative of xy, and I'll just add to it the derivative with respect to x of y cubed. Multiple terms are nice. Terms are separated by addition and subtraction, but multiple terms are nice because you can do their derivatives separately. Or for that matter, when we get to more second semester stuff, you can do their antiderivatives separately. Okay, so start with what you know as you look at this. The derivative of x with respect to x is just 1. The derivative of, let's go xy. You're taking the derivative with respect to x. So this y here, that's like a function. Okay? So you've got the derivative of x times y, and that requires the product rule. Okay, so I'm going to leave x alone. The derivative of y is y prime. Plus, take the derivative of x with respect to x, that's just 1. And I'll leave the green piece alone, that's y. So what you see here in yellow, this yellow thing is this. So now go to the next term. So plus the derivative of y cubed with respect to x. Well, I see two functions. An outer function that's cubed, so 3 something squared. Okay, the inner function, which is y, and y's derivative. The derivative of the inner function is y prime. So this turned into this when you took its derivative, right? So the goal is to find y prime. So you're going to do some algebra here and isolate y prime. So every term with the y prime in it, I'll keep on the left. And this one I'll move over. So the right hand side is going to be 1 minus y. And the left hand side is xy prime plus 3y squared y prime. Now I want y prime. It shows up in two of the terms, but I can, think I can factor it out. So it only shows up in one spot. So divide both sides by this quantity, and you're going to have y prime isolated, x plus 3y squared, x plus 3y squared. This one finishes a little differently than the last one. Notice in the last problem I said, hey, you actually know what y is in terms of x, so just go back and substitute it in. Well, I don't know what y equals in terms of x. I don't. So I'm going to leave this as my answer. In the problem before, you did know. Okay? If you went back to the statement you started with, you did know what y was in terms of x. So you plugged it in the end. Here you don't. So here, if you were going to find the slope of a tangent line on a curve, you'd need both the x and the y coordinate to find the slope. So we call that implicit differentiation. You notice you didn't have to do any natural logs, but you didn't explicitly set the problem up so that it was y equals, right? You didn't explicitly solve for y before you found the derivative. You just started taking the derivative of both sides before y was explicitly solved for. And that's why they call it implicit differentiation. Places where students usually struggle is they don't understand why when you're taking the derivative of xy with respect to x, why you need the product rule. And then they don't understand why is the derivative of x with respect to x1, and why is the derivative of y with respect to x, y prime. So they struggle a lot there. Also, when they do the derivative of y cubed with respect to x, they want to say 3y squared, not 3y squared y prime. So you have to pay attention to what variable are you taking the derivative with respect to, right? And if it doesn't match the variable you're working with, like when you take the derivative of y cubed with respect to x, y doesn't match x. So y, you're going to treat as a function of x. There's another function, right? There's chain rule in there. That's hard. 3 and 4 are historically some of the harder problems for students in concepts. So good job. Hope this helped.